Good morning. Today we're working with parallel and perpendicular lines, and we are going to be working on the Geoboard to show some of those lines in our two-dimensional shapes. We're entering Module 2, Polygons and Symmetry this week. We'll be working with quadrilaterals, triangles, lines of symmetry, and today we're wrapping up with the parallel and perpendicular. So your essential question, how can I identify parallel and perpendicular lines? And your I can statement is that you can do that. So notice this right here, this picture. Can you solve for the unknown angle? So make sure that you've got something out that you can write on to solve these problems. So I know that the outer angle, this part right here, is a right angle. Right angles measure 90 degrees. So if I need to find this unknown angle, I can take the 90 degrees and subtract 35 degrees from it to find the missing angle measurement. So go ahead and write that down. 90 minus 35. Pause the video and solve it, and then hit play after you've got it. Did you get 55 degrees? Next, the combined angle measure of this is 50 degrees. So this all together is going to be 50 degrees. We know that this part of that larger angle, this smaller angle here, is 15. So think about how would we find this missing information? We would subtract 50 minus 15. So pause the video and figure that out. Did you come up with 35 degrees? That is correct. Angle H is 35. So we have a new one. The combined angle measure is 140 degrees. So we're talking about this larger angle here is going to be 140 degrees. We know that this part of it is 25. So we're figuring out what this part would measure out at. So without getting our protractor out, we can subtract 140 minus 25. Did you solve it? Did you get 115? 115 degrees plus 25 degrees is what would give us our 140 combined angle measurement. Next, the combined angle measurement here is 115, so that means that this angle plus this angle would give us 115. Notice there's no number here, but we do have a clue. What does this tell us? This is just a sign to tell us that this right here is a right angle. So think back, what measurement does a right angle have? It's 90 degrees, right? So to figure out t, we would do the subtraction here, 115 minus 90. So go ahead and do that. And what did you get? This is one you could think through also. You could just go back, if you go back 15 to get to 100, and then another 10 to get back to 90, you find 25 degrees to be your answer. Ooh, look at this. You see this little thing right here? This means angle. It looks like the less than symbol, but it means angle P equals 50 degrees. So the combined angle measures, we've got this 85, so we need to figure out what 50 plus 85 would be. Go ahead and add that up. Did you get 135 for the total? That is the correct answer. Now, this is another way you might see angles named. There are two ways. One is from an outer point to the vertex to the other outer point, and the other is just by the vertex. So in this case, it says that what is the measure of angle A, B, D? So it starts with A, the vertex is B, and goes through D. So that is what we're trying to find out. We know that this one is 20 degrees, and we see this little clue again, so we know this is 90. So we need to add 90 plus 20. Go ahead and add that. That one's an easy one to do in your head, 110 degrees. If I take the 20 as 10 plus 10, 90 plus 10 gives us 100, and then another 10 to get to 110. Make a plan. Suppose you draw a line from the center of a clock face to the number 12, like this. When the minute hand gets to the 3 on the clock face, like this, the line and the minute hand form a 90-degree angle. What angle does the line and the minute hand make when the minute hand is on the 2? So right here, I want you to take a second to look really closely at this clock. We know that from here to here, that creates a 90-degree angle. What else do we notice about this part? If we look at how many sections it takes to make 90 degrees, we've got one section here, a second section, a third section. So that means we could take the 90 and divide it by 3 to find what angle each piece would be at by itself. So 90 divided by 3 is what? 30. So that means that every little section like this is 30 degrees. So if we've got the minute hand on the 2, that means we've gone 30 degrees and 60 degrees. So this would be a 60-degree angle. That's really helpful when you're looking at a clock face to remember that 30 degrees for every 5 minutes that you're apart, that the rays are apart from each other. Curiosity, what do you notice and what do you wonder? There's a whole bunch of things going on in this picture. Can you find some perpendicular angles? So perpendicular means it creates right angles, it crosses at right angles. So I could name this line by the 2 end points at the ends of the lines that we see. So line CF is running perpendicular to line BL. Line CF is also running perpendicular to line AM. I could name just the line segments, which would be from the points just inside here, because they're line segments because they have specific beginning and end marks. So I could say line CF is running perpendicular to line segment DH and line segment EJ. So that's perpendicular. Do you see any parallel lines? Remember, parallel means that it stays the same distance apart. So line BL is running parallel to line AM. Line CF is running parallel to, I'd have to start here, H to the ray HK. I could do segments here too. I could say line segment DE is running parallel to line segment HJ. And then we also have at one that is just intersecting. It's not perpendicular, but it is intersecting. This ray right here, HG, is intersecting line BL. It doesn't form a right angle, but it still would cross. All right. So just a reminder, these are examples of intersecting lines that contain one common point where they cross, just like an intersection when you're driving. Parallel, they are always the same distance apart if two things are parallel to each other. Please always remember that the L's in parallel are parallel. That's one of your hints there. Perpendicular, intersecting at right angles. So they are intersecting lines, but they're special intersecting lines because they form a right angle. So that brings us to our assignment for today. Lines and shapes on the Geoboard. It says we've got a parallelogram here. Do you see parallel lines in this rhombus? Do you see perpendicular lines? So down at the bottom, you're going to pull up any of the true statements. So one of them says the red lines are parallel. Well, that's true. Red lines are running parallel to each other. Then it says the red lines are perpendicular. Nope. They don't cross each other. They don't form right angles. They are not perpendicular. So you wouldn't put that up there. This one says no lines are parallel. Well, we already said the red lines were parallel, so this isn't right. So there's not a set number of true statements. You just need to look and see which ones are true. Next one, we have a triangle. Do you see parallel lines in this triangle? Do you see perpendicular lines in this triangle? So we do have a set of perpendicular lines or line segments here, but it's impossible to have a triangle and have parallel lines. So keep that in mind. Next, we've got a quadrilateral here. Remember, to be a quadrilateral, it has to have how many sides? 4. It needs 4 sides. Quad means 4. And it says, do you see parallel lines in this trapezoid? Do you see perpendicular lines in this trapezoid? To be a trapezoid, remember, it has to have 2 lines that run parallel, 1 pair of parallel sides. So you know that there's going to be something. So double check when you look here. Now, I'm also going to tell you these are the purple ones, the lighter colors here. This one is red. This one is white. Then you are going to create 2 shapes. It says construct a quadrilateral with only 1 pair of parallel sides. Remember, to make a quadrilateral, you just have 4 sides, but this one's tricky because you're going to have only 1 pair of parallel sides. So you're going to go to the Geoboard app, and it has the problem there for you also, and then just start working with it. Remember, quadrilateral, you need 4 sides, but only 1 side of parallel sides. Now, a reminder on how to share. You'll go to this down here, save image, copy to clipboard, then go back in, click somewhere, and Control V for victory. Over here, you're going to type in, explain how your shape matches what the description. Last one, construct a pentagon. A pentagon has 5 sides. So the very basic pentagon looks like a house or a birdhouse. You're going to make one with only 1 pair of perpendicular sides and exactly 1 acute angle. Explain how your shape matches that description. And that's it for today. I hope you have a wonderful day, and I will talk to you soon.